All right, welcome everyone to, yep, my bad, February. So don't look at the slide. Started on a good point already. Okay, so as we get going with February's Azure user group, not January, big thank you out there to our sponsors. So without these guys, none of this would be possible. So Ko-Fi, they put up all the beer, the pizza, and Microsoft for the accommodation. So without these guys, this would not be possible. So big thank you. They're very important to us. This is a community group. So we really are keen for people to get involved. If you'd like to contribute, we've got a bunch of spots available. If you have a talk, it doesn't have to be the latest and the greatest. It could just be your experiences with Azure. In fact, that's what we'd like to hear. Drop an email to that email there. We've got plenty of opportunities there available for anyone. So get involved. Let us know. We'd love to hear from you. Just a few updates this month. Things are getting a little bit busier. Azure Monitor pipeline transformations. So as you're sending stuff to Azure Monitor, you can get in between and modify and manipulate the log data as you're sending it there. It's in preview. Got a few VMs that have dropped in the last month and a bit. So this one here, confidential VMs, it's all about that security. We've got DC V6 and EC stuff V6, lots of letters. We've got Azure Container Storage. So this allows you to sort of like mount the storage on there. So for Kubernetes, you want to have a single storage that you're just mounting on there and using your Kubernetes environment. It's pretty cool. We've got some improvements for app gateways. So we've got the X-Forward grouping rate limit. It's a big mouthful for an app gateway. WAF v2, it's gone into preview. So if you're interested in that, that's pretty cool. We've got some DRS 2.2 has come out as well. It's for app gateway. So just new rule sets, updating to the latest OWASP and all that sort of stuff. More VMs. I should have put those together. So this is the Intel ones. So just more performance, execution, better VMs for you to use. And more. Something that I thought was pretty cool. So for those people that are using NAT gateways, you can now have NAT gateways that are across your zone redundancy. So that's pretty cool. Is it GA? I think GA, yeah. Use the delegation for SAS tokens. So previously we had for blobs, the user delegation. So that's enter auth for your SAS tokens. So that was released previously for blobs. Now this just brings up the other offerings in storage account up to that level. So you can now use user delegation for tables, files, and queues, which is pretty cool. And I think it's getting very close to the end. For Cosmos DB, we've got Fabric mirroring. It's come into preview. So for all those people that are using Cosmos, some thumbs down. Cosmos, Fabric coming together. That's gone into preview. Cool. So a few resources. So we've got the Slack, we've got the YouTube, we've got some training. These blogs, these slides will be available later on. But without any further ado, tonight I want to hand it over to Todd Whitehead. So Director, Intelligent Apps and Cloud. Sounds really good. So Todd, technology leader, everybody knows Todd. So I don't know if I need to do any much further introduction.
Probably safer not to.
It's safer not to.
Let's leave a little bit of space for some success.
We are super keen to see the Wile E Coyote approach to AI for backyard Beast management.
And I bet that's a sentence you didn't really think you'd ever have to say.
But now I have, so I feel complete.
Excellent, excellent. Thank you.
I've always wanted someone to do this to
He's doing excellent. Why didn't you do it? Let me steal this. We still live in a world where dongles are a thing. Oh, sorry. Thank you, Ray. Just talk amongst yourselves for. It's related. What's one of the dongles? Doesn't come with the dongle that I have, so I have to go to the emergency dongle.
Of course, I do have a question.
No. Oh, sorry, they're outside.
When are you going to recognise whether it's a?
Hey, that worked.
already done that.
That worked.
Oh, I
I'm
want
not
to see them
silent
both
on
together.
turkey.
Yeah, Cylon turkeys. I don't know.
We could. Hopefully, I've got mouse. We got that. Hopefully, I've got. Okay, awesome. Welcome. This is great. This is a great turnout. Just trying to figure out where I'm going to stand and what I'm going to do. So, as Damien said, my name's Todd Whitehead. I think I know a lot of people here, not everyone. My talks kind of start out as really good ideas late at night. And then as any relatives of mine who are here will attest to, they can go off the rails, not so much in terms of fun and delivery, but more of scope and cost management. So we're going to go through on a bit of a journey tonight, and this one's a little bit different from the talks I normally do. This one is a little bit more of a tales from the trenches, a bit of a speed run through what I've sort of have been looking at across the AI space in the last couple of months. I'm developing this talk to present in NDC Sydney in April. So you're getting kind of the sneak peek, and be very keen for any feedback, questions, and any insults can be directed to Damien. So the Wile E Coyote approach for backyard beast management. Where on earth did this come from? Well, first I should put in a quick shameless plug. I now work for an amazing company called NextWave, and we are actively recruiting for amazing people around Azure and AI. I spend all my day thinking about Azure and AI. If you are at all interested, please reach out. But what have I been doing around AI? AI sounds amazing, and I feel like probably I'm not alone. We've gone through a bit of a hype cycle with AI. There's lots of cool stuff we do with AI, and AI kind of shines a light into some dark corners of our Azure environments and our data environments and our business rules, maybe that need fixing. So a lot of the time I'm working with customers around fixing those, which are super important. Not always the funnest thing in the world, but super important. So I wanted to do something a little bit different, a little bit fun, and try and get a little bit of that magic back, as well as look at some things in Azure and AI that I hadn't even touched yet. Because let's face it, no one can keep up with everything in AI, even on Azure, forgetting everything else that's going on. So this is an artist's impression of my backyard. It's kind of what I look out to. I live at a place called The Gap, which, because I'm in Brisbane now, most people will kind of know it's out that way. There's mountains, there's a gap. What do we call it? The Gap. We kind of like that in Brisbane, right? But it's very leafy, it's very green. And provided you don't have monster hailstones trying to kill you or the occasional cyclone trying to relocate your house, it's very, very pleasant. And there's certainly lots of animal life. Right? We kind of like to make fun of, American tourists particularly and try and scare them with drop bears. And I don't know why. There's plenty of things legitimately they should be scared about. We get the occasional spider. Sometimes there's a brown snake swimming in your pool when you want to go for a swim. These are just things we've learned to deal with. And sometimes his bigger brother pops in and, pops up to say hello. That's just part of living in the Gap. Or, and let's be fair, you have to deal with earthworms that are of an unusually large size when you're gardening. But, there's no maliciousness in it, right? That's just there. They don't give you any grief. It might give you a fright. But probably the best part in our household, we certainly have lots of bird life. And cute life. We have possums that come and sit in your, and I just love with these animals the look they give you. It's like, oh God, this guy hasn't learned anything. But we have lots of animals that come and visit us. They're very friendly, they're very colourful. By and large, they get on. They're pretty tame. Oldest here, hand feeding them. Not a lot of drama. It's pretty much, it's heaven. Look at this, we've got birds. We've got less attractive birds. I don't want to say it in a mean way, but most of the time everyone gets on. So if you wanted to sort of think about this experience, keep in mind for me, my jungle friends. A little bit like that, and I like the fact that I didn't realise too I was making this. But it's kind of like that most of the time. But like every family, there's always one. There's always one that's just got to stir the pot. And in my case, whether you call it a scrub turkey, a brush turkey, or a bush turkey, I prefer its Latin name, bugger everything up us, causes us some problems. What sort of problems? Well, that harmony we liked and we get a lot of, he just likes to stick his head in and cause trouble when everyone else is just trying to have a bit of an afternoon snack, not unreasonably. And because of my growing family, I have an excellent little office pod. There it is there. It's kind of picture the size of a metal shipping container. Very nice. It's where I keep my Commodore 64s and all my other things that you need to keep safe, and that's where I work. But it's got a tin roof. And occasionally the birds come and visit me, and that's kind of nice, that's kind of serene. But again, there's always got to be one. There's always got to be one bugger that comes along and ruins it for everyone. And he seems to take special delight in leaping from great height in those palm trees in the background and landing on my metal roof when I'm in the middle of a meeting, trying to get me to say a bad word. So it's annoying. But apart from that, they actually do a reasonable amount of damage. So again, this is a nice little shot of my backyard, and we see evidence everywhere. So point A is the nice hole he decided to make in my lawn. Plant B is where the tree should be that he sat on until it didn't want to exist anymore. Point D is where my lights should be until he decided to try and sit on those until they went anymore. And what am I doing? I did the wrong way around. Point D. Point C is the bird feeder you saw earlier. Very useful when it's horizontal, less useful when it's vertical, because he decided that's where he should sit. So, causes trouble. So this was clearly a problem. And, being in the age of AI, I thought, what does AI suggest? So I asked it, and it gave me some really concrete suggestions. The first one was, remove all the grass, dirt, and insects from your area. Well,
It's pretty concrete.
yeah, that ain't gonna. Suggestion 2, build a tall fence. As you can see, that causes the scrub turkey no challenge at all. Option 3, use mirrors because the appearance of himself will think there's another predator. As you can see, he's completely terrified and traumatized by looking at himself in the mirror. Not so much. And probably the one I really could get behind, startling noises. As my family will know, the frequent call of "get in your tree" rang out across our yard in multiple times. Because I have no ill will towards the scrub turkey, who I call Barry. We'll call him Barry the bird. I just want him to leave me alone and stop messing up my life. So I would yell, "get in your tree." He obviously ignored that, took that as a suggestion and moved on. So that wasn't effective either. But I had a secret weapon. Because I'm quite old, which means I grew up watching movies in the 70s and 80s and even into the 90s. I knew with a can-do attitude, some slick shoes and some marbles and some broken Christmas ornaments, I could stop nuclear war, stop people trying to rob my house, and get the gold and the pirate treasure. There was nothing I couldn't do if we could just think about it. But maybe more importantly than that, and hence the reason for the title of this talk, is I spent a lot of time as a kid watching cartoons. And if there's anyone that inspired me, it was Wile E. Coyote. He was a guy who never gave up. He didn't let persistent failure stop him. He was always thinking of new and innovative ideas. So I thought, well, maybe this is my solution. So I asked Copilot. I said, Copilot, what do you think? Do you think Wile E. Coyote is an admirable kind of role model? Copilot was on board. It listed out immediately all the skills that Wile E. Coyote's approach to thinking about things could bring to AI. I particularly like relentless iteration. Of course, you could put relentless iteration in the face of failure, but they didn't. I'm okay with that. A bit of systems thinking, creativity, unshakable focus, resilience without resentment. I've got to be honest, I struggled with that one. Resentment did start to creep in. And accountability for outcomes was obviously off the table. So, being Copilot, it then went on to propose a management framework based on this. It proposed a leadership framework. It proposed a self-assessment tool. And it also proposed leadership training exercises you could run with your management if you so chose. Because, you know, that's what Copilot does. It helps us, even when we don't need it. So I took a step back and I thought, okay, I'm a developer. I come from that background. It's my mindset. I always want to build a solution. Then I slap myself and go, wait a minute, there must be a solution for this. You know, there must be some off-the-shelf solution. So I had a look. I went to Bunnings, and sure enough, you can buy, what is it, Safeguard Scarecrow, which has a motion detector and squirts water at things. Not unreasonable. My problem with this is I only wanted to scare this guy. I didn't want to scare all of those wonderful things. I just want to scare one thing. So that was not specific enough. We could go up a little bit higher and go the bird scare gun. Gas-powered explosion scares the what out of everyone. But again, not very selective and a little probably likely to lead to complaints from the neighbours. And just because we're talking before about remote metal welding, there are, of course, autonomous bird-repelling lasers, which sound cool, because who wouldn't want an automated bird-repelling laser? But again, not selective, and possibly might get me reported to a very different set of federal authorities. So none of those were so great. So what do we do in this day and age when we can't find what we need straight away? What do? That's right, we go to YouTube. So I looked at what other people had built. This was an interesting one called the Bird Sweeper. It sweeps birds off. Now, I like it because it's humane, but let's face it, it only covers one very particular use case. So probably something more flexible, more generic, and probably hard to think of anything more flexible. Possibly two things. One, I'd have to go and refill the darn thing every hour, the number of animals I have it.
Be a good container.
And, the humaneness of that approach, maybe not, maybe questionable. But anyway, it did help solidify what my requirements were. Because let's face it, when you're working with AI, most of the important thing is actually figuring out what you're trying to do. Because everyone gets super excited about the technique. So I kind of boiled it down to this, right? I wanted it to be humane. Should have put as humane as possible. Might have been a better way to put that. I want to be selective on the species. It's got to be appropriate for a backyard. I want it to be modular because I want to be able to add and tweak and change things. I decided something water-based might be the way to go because it's easily accessible in the water. It's not super destructive. And could we do it? I need to cover a large area because I have a large backyard, not the little top of the pool. And obviously, now that I'm on board with the Wile E Coyote management framework and a self-assessment tool, I needed to be something that Wile E Coyote could get behind. Right, so coming back to those principles, I can get on board with most of them. I think the accountability for outcomes is one I'm just going to leave on the table, and the resentment I'm not committing to that. But the rest of them, absolutely. So taking that mindset and approach, we're going to rapid prototype some solutions. First one was as simple as you can get. Hey, I've got a hose. I can connect to things and I can squirt things. So I did that and it worked. As you can imagine, it's not an incredibly sustainable solution. It did tend to dip my productivity because I couldn't stand there all day. And I could only squirt at one thing. I thought, oh, maybe I can add a sprinkler and a tap. Well, that's good. I don't have to hold it anymore, but I still got to turn the tap on. So that's annoying. So the next logical step, obviously, was to have something like a sprinkler, and we need an Internet of Things powered tap. How do we do that? Well, you buy it on Amazon like everything else, right? So this is an Eve Aqua costs about $50 or something. Hook it up to the tap, it hooks up to your network, and you can go, sprinkle please. So that's what I did. And there it is there on the right. Now, I'm not going to lie, there was a slight downside I hadn't considered to this approach, which was kind of about here. Yeah. So, but that's okay. It's not, remember the framework? That's not a failure, that's a data point. So we've got the basics, we just need to tweak it along a little bit. So out of this came our first real kind of solution. Okay, the ACME Bird Defender 2000. It looks suspiciously like a set of sprinklers that have been nailed to a piece of wood, and that's because that's what it is. But what's nice is each of these little things is bendable and aimable, so we can kind of cover an area. And you can also tweak for a stream or a miss, so you can control the distance. So that seemed fairly reasonable. So now I've got something I can engage the offending. He's sitting there nicely tonight, that's good to see. But now I need to detect this bird. So how am I going to do that? I co-piloted around, and this was the most recommended solution. It's called BirdNet. This was a AI audio detection model developed by some very, very clever people at Cornell University and all these places, and it's used all over the world to do things. And it's actually pretty neat. So this is run by a little Raspberry Pi, the red box at the front here, and a very expensive $5.50 microphone, USB microphone. Not a good microphone, but it's good enough. And what it does when you run it, it's just listening all the time, takes samples, runs it against this BirdNet model, only using CPU here. So there's no GPU, there's no NPU, this is just CPU power, but it's actually pretty effective. It gives you, this is, I can't remember, I think about a weekish after. So you can see here it's tracked. We've got 62 total species detected. It gives you a little picture, how many times they were counted, all those kind of things. And it, even when birds fly over your house, if they make an out, even this little microphone, good enough to pick that up and inference it and give you kind of the answer. So that was good. Gives you all sorts of stats, all sorts of exciting graphs and things, and it's all wonderful. You get to understand the bird life, when they come, which part of the day, what's new, all this kind of, there's lots of good stuff in there. There's only one problem. If you have a look at that top 10 list, you notice something missing. That's right. Barry, I mean, the scrub turkey. Turns out scrub turkeys don't make a lot of sound. No, they don't. They don't. They do make sound. And on one occasion, I captured that sound. I was so excited. I yelled out let's just say a really excited yell. I go back and I look at my dashboard, nothing's there. What the heck? It went gobble, gobble, gobble. It made a noise. Why isn't it there? Well, it turns out, unfortunately, the wonderful people that built this actually looked at responsible AI and ethics and all those things and put a little filter. So if during the recording there's a human voice, it throws it away. So it doesn't actually help. So me yelling excitedly didn't help. Disappointed. Responsible AI hates me too. But it was an encouraging start. And what I did like about it, it also came with things like MQTT built in. So you could send notifications off and messages off. So this could be part of a bigger system. So that was encouraging and kind of a good lesson. But it became clear I needed something better. I needed some video-based detection. So even if these birds aren't making any noise, I can detect them and classify them. So the next step was to roll out this thing called BirdLens, which again, another AI model, but this came with a really nice kind of container-based solution. So it does a few steps. I think how to do this. I'll do this over here. The first thing it does is it has a passive infrared sensor. And if you have a look up here on the table, this, oh, the camera's fallen off. Pretend the camera hasn't fallen off. The little white thing there. So it'll actually detect, oh, there's some infrared heat. I better go and have a look at what it is. Right, so it's not just recording all the time. Kind of handy. The next thing it does, it turns on the Pi camera. Tiny little Pi 2 camera, not great, 8 megapixel quality, yeah, but good enough. And the first thing it does is detection. Is it a bird or is it not a bird? That's the only two things the first model cares about. Super fast, super easy to get a result. What it then does is hand it off to the classifier model to say, great, you got a bird, what is it? right? And that's a bit harder. It's actually got to do the analysis and go, okay, it's a bird, it's a scrub turkey, it's a sulphur-crested cockatoo, it's whatever. And you can see it's got quite a nice little architecture here. It's a nice little Nginx gateway that everything goes through, so everything can talk to each other. You can make it really nice. It's got a nice UI. So that's what it looks like there. So again, it's only a Raspberry Pi 5. Nice, but not great. Again, it's only using CPU for its inferencing, no GPUs, no NPUs, no any of that thing. I mentioned the cameras, yeah, it's okay, but it's good enough. We've got that. Now, it didn't support MQTT for notifications. It used this thing, NTFI, which I guess you pronounce notify, even though they like save money on vowels, which is great. It's a web-based thing, but I wanted to use MQTT, so that'll become important later. We'll fix that. So that was kind of cool. So this gave us the basis of the ACME Bird Defense System 2000, trademark pending. What do we have? We have a tree, we have Barry. I want to get Barry into the tree. I think it's really important in AI projects we keep our eye on the prize. All right, so how are we going to do that? Well, we've got these detection devices. They can detect and classify birds using multiple different kind of sensory inputs. That's great. They can, in a minute, both send MQTT messages to say, hey, we've got a bird. And then this is where we're going to put in some bit of agentic AI, because normal AI just doesn't cut it anymore. So what we have here is a little 10-inch rack with a couple of little mini Spora machines running some Arc-enabled Kubernetes, which ultimately is running an MQTT broker. It's a little bit of overkill at the moment, but it's also running Azure Foundry Local. I don't know why I put Azure Local there. Who's heard of Azure Foundry? Well, sorry, let me rephrase that, and I have this on the slide later, because I keep changing these. If you know Azure AI Foundry, now called Microsoft Foundry, who has heard of that? Who has used it? Who has? What about Foundry Local? Okay, one. This is running Foundry Local. We're going to cover that in a minute. Basically, this is where our agents are going to run for this local scenario. Okay, that talks to that wonderful tap. We expose that as an MCP endpoint, so the agent can do it. The Model Context Protocol. Great, which should activate the, and I've forgotten what I called it, the Defender 3000, whatever the heck I called it, which should then distribute water in a random and violent way onto Barry, who should then transition off to his tree. Barry in the tree and no Barry. That's the end result. That's what we're after. So let's have a look at an action. Happens pretty quick. Birds classified. Definitely a threat. The defense system is activated. Words, Barry leaves from his tree. Might, just for the heck of it, play that again. Now, one of the things I want you to notice is how long each of those stages take. Yeah. So the PIR, motion detected, bird very fast. Defense activation, the agents kicked in. Okay, so that last bit took the longest. Actually, the defense activation means we told the tap to send water. And that took longer than all the other steps put together. Okay, so so look, it worked. Great, V1, it worked. Couple of things to note. Part of the problem was, it's probably hard to tell, you're looking at the rear of Barry. That's probably the nicest way to put it. Because if you'll notice, all my wonderful defense system is facing Barry's usual, angle of approach. Barry, being the chaos engineer, he decided, that looks dangerous. So Barry walked the entire way around my house and came in from behind. So the first time that the detection system could detect him was when he was right up close, not hopping over the fence as he has every single other time I've ever seen him. So that was a problem. The detection arc was very forward focused and couldn't necessarily pick him up. There were some problems with the hardware too, because remember on those Pis, we're only using the CPU for the inferencing. But at the same time, in these kind of AI solutions, we've also got to capture the video, store the video, and hand the video off to the file. On a little Raspberry Pi, that's a lot of work. That there's a lot of contention there. And the CPU, it's only got the CPU to help with this inferencing. so it's a bit slower. And probably the biggest two problems are the engagement envelope, because you can see there's another, you can't see in this picture, I'll show you later. There's another one over there, right? So we've got overlapping fields of fire because, all the military people tell me that's what you should do. But if, as in this case, Barry approaches from the rear unexpectedly, there's no way to move those defense systems around. And my biggest complaint was that latency. We detected, we classified, we said, yeah, wet him. And we waited like 5 seconds, by which time Barry's probably moved, a meter or two. So we need to address that. But again, these are all good data points. And just, to celebrate a little bit of victory together, can we celebrate the fact Barry did in fact get in his tree? I'd have to say he didn't do it with the look of terror I was kind of hoping for. It was more a maliciousness and, writing your name down in a book. But, it was okay. So we need to up our game a bit. So now we need to build the Bird Detector 3000, which is the other one sitting next to it. Still a Raspberry Pi, bit more memory just to help out, bit of a better camera, wider field of view. That's really hard to say for some reason tonight. But we had some secret sauce. If you be able to see on the photo, that little black thing there is actually the heatsink that's covering this. And this is the Pi Hat Plus 2, which just does not roll off the tongue at all. But it's a tiny little NPU. We have CPUs, we're used to GPUs. Now we have NPUs. Kind of the GPUs are a general graphics thing and they're handy for AI because they do lots of number crunching, but NPUs specifically designed for AI. Won't help with graphics terribly much, but gives us, in this case, 40 TOPS or 40 trillion operations a second. Pretty neat for a tiny little card on a Raspberry Pi. It's made by a company called Halo who have optimized models to run specifically on that. We'll have a look at that later. There's pros and cons to that. The great thing is they're super efficient. The bad thing is you can't just take any kind of Onyx model and throw it on there. You've got to convert it and do some jiggery pokery. But better. So once we have that on board, then all of a sudden we've got lots and lots of detections happening all at once. So we've both got detection and classification happening pretty quickly. And it's a little hard to see, but if you have a look up here, this is the 4 CPU cores on the Pi. You can see they're not doing very much, right? Because everything's been offloaded to the hat. So all the Pi has to do is record the video and save it, right? So gives it much more headroom. The hat has, I think, 8 gig of memory as well. So all the models running on that dedicated bit of silicon, much better results. And it can go further than that. So we can do things, for example, rather than just detect it with a bounding box, it can actually, you can see there with the red coloring, you're going, that's the bird. Not that it's in that square, it's segmenting the image to say this is exactly where the bird is. It can do other things like if it's people, it can tell, it can work out what parts of the limb are moving. It can do all sorts of cool things. So it gives us a lot of capabilities. Cool. We've uplifted the AI detection piece. So that's a good start. Now let's talk about the actual agent that's doing that bit of work. And this is where we jump over to, that's where we jump over to. Thank you. Azure AI, Microsoft Foundry. Stop changing the names of things. Okay, so if you've used this is basically when it started, let me put it this way, when it started, it was kind of the code first way on Azure to do AI, right? You had Copilot Studio for your low code, no code kind of approach. And you had Microsoft Foundry. It's got a huge collection of models from everyone, not just OpenAI, but Anthropic and Facebook, all the models that you can go and do. But now it's got things like workflows and it can host agents and it can do all sorts of cool things, lots of playgrounds, very, very cool. You can go in and see all the models. There's like ranking tables of what models are good at what and all these kind of things. If you look very closely, there's a little box. There it is, yes, Foundry Local. And that's what we were using for this. So if we go into there, these are basically the models that are small enough or optimized to run on the edge. So you can basically run it on any hardware you own. So you can see here, it'll tell you exactly, they have different versions of the model depending on what hardware you want to take advantage of. And one of the cool things you'll see in a second, I'll just show it now there, is, for example, you can say, go and get me this model, And it can actually look at, well, what hardware have you got? Have you got a GPU? Have you got an NPU? Have you got a CPU? What type? Have you got AMD? Have you got blah, blah, blah? And it'll pull down the optimized version for your platform. So it runs as a service, locally, does the models. If you've used, what is it called? Not OpenLlama. OLLAMA, thank you. Or there's a whole bunch of them. It's kind of that runtime development environment management thing wrapped up in one that you can do. And it's pulling those for you from Azure AI Foundry. Funnily enough, I grabbed this screenshot and Microsoft still called it AI Foundry, so I don't feel so bad. So how does it look to use this? So let's have a look. I've installed the CLI tool, which has changed names 6 times in the last 3 months. So don't ask Copilot how to do it because it'll tell you the wrong thing. But yes, you just go Foundry, service start, and basically there you go. You've got a local endpoint. This is where the models are going to be served from. We can see it's running, and we can also see, based on the computer I had it running on, it's installed different acceleration libraries. For example, one of them there is for CUDA, because I had an NVIDIA graphics card. If you had a different graphics card or an NPU, it would pick up a different one. We can list all the models that it's got available. You can see there's a whole bunch of them. It'll tell you what, it has GPU, CPU acceleration, how big it is, what license it's under. And there's the direct name. If you don't want to leave it up to the service, you can specify exactly what you want to run. And particularly to tell you the size. Because when you first start out, this sounds really cool. I'm going to run it on my graphics card. Then you realize most graphics cards, particularly if you've got a new one, they've got like 8 gig of memory, right? Luckily, I've got an older, this is a 3080, which had 18 or something. So for some reason, it got bigger. But yes, graphics cards these days, and talk about that later, are a little bit more of a problem. And then we can just start a model. And if you've ever done Docker or anything else where you say, Docker, run, and the name of a container, it does the same thing. Do I have it locally in the cache? No. Okay, I'll go and get it, pull it down, and then I'll start running it. These are a lot bigger than most Docker containers, but hey, you get the idea. So I can run here whatever I'm running, GPT OSS 20 billion, and you can see there it's got the CUDA GPU. So it's going to take advantage of all the NVIDIA hardware to do its thing. So how does it look? So down at the bottom here, it'll spin up you into a nice little chat interface you can use to test it out. And if you have a look at the top, this is the GPU stats of the card. The big one here is the memory, because it's basically loaded that model entirely into memory. And then up the top here, it calls, what is it called? Video encoding. It's really the CUDA cores, how much of the CUDA cores being used. And you'll see, as I've now asked it a question, you'll see this huge spike here in the CUDA cores, because it's actually starting to use that, which I learned to check because sometimes I did something wrong and it was using the CPU and I was going, why is this thing so slow? But anyway, you can see here from the response, it's not too bad. And this is a 3080, which is what, 4, 5, 6 years ago? I don't know how old the video card is. But you just can't buy video cards with more RAM anymore. And for these sort of models, it isn't as much about the performance, it's about the RAM, so you can load the model in the first place. But that's cool. So we can run these kind of models locally. We can do it, pulling them from Azure AI Foundry or Microsoft Foundry, depending on which name you want to use. Cool. So we can do that. So that's what we've got to run our agent. The last piece of the puzzle you saw mentioned before was MCP, and I'm not going to go into it in any great detail. In fact, I think, Dan, remind me, I did a talk here like a year ago on MCP, so I probably should put the link to that session in. But the analogy people use for MCP is it's the USB for AI. It's a way to connect things to AI. I changed that, and I want to be really specific and say it's the USB-C for AI. I'll show you why that is, right? But basically, any kind of tool you've got, any system, any service, you can expose it in a way that any of these AI agents can use it and know how to use it. Lots of cool stuff. So putting that all together kind of makes a bit more sense what we've got now. We've got some CPU inferencing going here. We've got the MQTT messages coming over to here into the hub. That's, remember, we're our broker, our Foundry local, that should say, and our agent code is running there, which gets these messages from the queue, decides what to do based on it. So, for example, if there was a scrub turkey and a beautiful, shiny, happy parrot, I didn't want it to squirt it because I didn't want to squirt the parrot. So I gave those instructions in the prompt to the agent, and then it would take care of going, oh, there was a this and a this, therefore I won't do that. Not particularly complicated, but it's a good start. And the water squirting did thing. But as I said, latency was our issue. The inferencing on the CPUs, not a great drama. I went over and looked at the bottles, not a great drama. MCP, yeah, that was the drama. That took the longest. That leap there was the gap you saw in the reaction. And of course, you knew Apple would be behind it in some way, because to talk to that thing, I've got to go via the Apple HomeKit interface, which, you know, takes your request, it thinks about it, it puts on a long neck sweater, it does whatever the heck else it's going to do, and eventually it turns on your sprinkler. So I need to fix that. But it works. That's great. So that was kind of explaining what was in phase 2, phase 1. Now phase 2. So here's a bit of a simplified version. What I wanted to do was, remember those MQTT notifications we were getting? Yeah, we're doing stuff in the home lab, but what I'd really like to do is send it up to Azure, because it's, you know, the Azure user group, and it seems wrong not to do that, but I had some other things I wanted to do. So how do I do that? Well, there's a couple of ways. There is, in Azure, we have the IoT Hub, which has been around for a long time, and I've done lots of interesting demos with it, and it's been great. It does support MQTT, but it supports it in a very opinionated way. And by that, I mean, it doesn't do a lot. It's specifically designed to support the scenarios they want to do, device management, whatever. It's not designed for flexibility. MQTT is awesome because you can just go, send it to this queue. That queue doesn't even need to exist, and it'll just get there, right? It's all very nice and simple. So what I needed was something that could monitor those and pass it up to Azure. And luckily, even though the IoT Hub wasn't super exciting, Event Grid is. Who's used Event Grid? Go and have a look at Event Grid. It's very cool. One of the very cool things it does is it now supports MQTT properly. So not like IoT Hub. So again, it's designed to handle events at scale up to millions. It costs virtually nothing to run. It's super cheap. Although I did find one interesting thing, I kept getting deployment errors when I tried to deploy it. I couldn't work out why. You know how most settings in Azure, when you deploy them, there's an equivalent setting of, do you want to use zone redundancy? Turns out if you're deploying Event Grid into an Azure data center that has zone redundancy and you say no, you get an error. Which I thought was interesting. And I also thought, well, why put the flag in there if you're just not going to let me do it? So it doesn't cost any more. So we now have a zone redundant scrub turkey event queue to send little messages about this. But anyway, so we needed some way to get it up to there. And then once it's there, now we're into Azure magic land, right? Because we can just straight away hook that up as an event stream into Fabric, right? Just built in, we can do that. We could hand it up to a function to go and stick it in blob storage. We could do any of the Azure services super easily. So that was kind of the thing we needed. So what do you know? We need some code. So I created this thing called the MQTT proxy, which does all those things we spoke about. You can see there's different containers and yada, yada, yada. There's all that good stuff, right? And when you run it, I had it run because part of the problem with testing stuff like this, you don't really want to sit around all day waiting for the birds to turn up. So I recorded all the events for the birds and I could replay them whenever I wanted. So I could run this sim client off the real data. And here it is doing its thing. It's all wonderful. It's all lovely. I can go into Event Grid. I can see the messages arriving. Super fun. You can see there the little, whether you want Event Broker or the MQTT broker. Super. I can see it all arriving and I can see the function has grabbed it and written it out into storage, and I can open the file up and there's my payload with all the, the things you'd expect to see, right? Location, what species was detected, the bounding box on the image. So all the data was there. I could do whatever I want with. I don't know, 6 or 7 different parts of that. The infrastructure as code, templates to deploy it and all that kind of thing. But I have a confession. Didn't write it. I have another confession. Didn't even open VS Code, which is usually what I would have done. I would have opened VS Code and said, hey, GitHub Copilot, go and write this for me. So how did I write it? Well, I got surprised. I haven't had a look a lot at GitHub lately. So I created the repo for this code, fully intending to do that. And it popped up with this little box. It said, jumpstart your project with Copilot. I went, that looks interesting. So I gave a little prompt about what it is. It's a Docker container, MQTT, blah, blah, blah. Here's the services I'm going to use. see what it comes up with, expecting a kind of a scaffolded, hello world type application. Nope. It chewed on it for about 25 minutes, multiple agents. And here's what was interesting, and I didn't expect. It didn't just write the code. It was a whole team. So it would write the code, and then it handed off to another agent to review the code, who would come back with suggestions. Then it would create an environment in a container, because I said to do it in Python. So it installed all the Python tools, and even before it completed the prompt, it ran it in Python to make sure it worked. It created some tests. So it did all these steps. And I'm sitting there going, didn't expect that. It was quite impressive what it came up with. And then, it wrote documentation, it wrote test scripts, it wrote basically what I needed to get started. But, and again, I apologize, it's a bit small. The one thing I forgot to put in the prompt, it was about birds. And if you've ever done an IoT demo or anything IoT related, what do you always send in an IoT demo? Adam, what do you always send in an IoT demo? What sort of data? On the screen, do you? Temperature and humidity, of course you do, because that's what all IoT projects are about. So not unreasonable. But then what was interesting is I thought, I'll ask it to do something else. So I created another prompt under the thing, and I said, I want you to create some data files, some samples, but I gave it this bit of context. Represent bird detection events from an AI camera in a backyard in Brisbane. Because I learned my lesson, context is important. I want to give it the best chance of success. And again, this is not Copilot Studio. This is just on the Copilot interface. And I'm not going to lie, I was watching the cricket while I was doing this, so I wasn't paying a lot of attention to what it was doing. And it churned away. And again, I haven't given it the payload I had, but if you have a look at the payload it came up with, it's pretty remarkably similar. It understood if you've got an AI camera, you're probably going to want a bounding box to show where it is in the picture. You're going to want location. You're probably going to want some environmental temperature. I just think it likes putting environmental temperature in IoT, but whatever. Oh, I was impressed. Here's where it got really scary. In the notes of what it wrote, it said, I included 8, because remember I told it Brisbane, 8 common backyard birds: the magpie, the kookaburra, the rainbow lorikeet, the noisy myna, the white ibis, the cockatoo, the currawong, and the brush turkey. It did better than I did. Now, if you remember back to those stats from my audio detection, have a look at the list and have a look at what it came up with. Other than the white ibis, it was pretty much spot on. And that was impressive. And that was a bit of a little interesting moment, because a lot of the times when I've used AI to generate code, I'm not going to use the word vibe coding because I just hate that, but to really scaffold it, it's functional, but this shows a level of thinking about the prompt and thinking about the problem space that I hadn't seen before. So I thought that was super cool. Right. So that was good. But then I thought, okay, well, what's next? We've got those things. Obviously, we've got these bird events. We've got this very cool AI. The obvious thing is people would be dying to read a blog post every day that described what was going on in my backyard, particularly with the birds. And hence, getinyourtree.com was born. So obviously, the first things I did was grab Copilot and publish the Wile E Coyote Leadership Framework and Self-Assessment Tool. So if you'd like to go and take that assessment and see where you stand, please feel free. But we needed some way to write that blog post, because I sure as heck wasn't going to do it. So that's when I looked at something else that I hadn't looked at before, called the Microsoft Agent Framework. Who's heard of the Microsoft Agent Framework? Only a few. Thought so too. Fairly new. But if you've heard before, you might have heard of semantic kernel, because let's face it, Microsoft, like most big companies, if one thing is good, 2 must be better, right? So we had semantic kernel, which is very well put together, very enterprise kind of approach to building an orchestration model. And then we had AutoGen, which came out of Microsoft Research, which was super cool and super chaotic and not consistent at all. So what they said was, hey, radical idea. Maybe we should kind of merge those 2 things together so people don't have to build in different worlds. And that's what the Microsoft Agent Framework is. It's basically the best of those 2 worlds for building AI agents. And they can run in Foundry. They can run on your PC. It's open source. They don't care where you run. It's just an orchestration framework. So here was the next mission, to build the agentic blog bird, right? So we're going to put together, oops, not an agent, but we're going to put together a team of agents, right? We're going to have an editor who's going to be looking after the whole thing. They're going to have a researcher who's going to go and collect that data we've stored in Fabric or wherever the heck. We're going to have a copywriter. Basically, we're going to try and mirror what I saw GitHub Agent do in terms of handing things back and forth. And that website is actually published on a Azure Static website because they're free, and that's awesome. And that's published from a Git repo, and it's running a Hugo static website. So I also need, I need the content, but then I need someone who can actually go and turn that into some Hugo markup and publish it to GitHub for me. So there's a whole lot of roles, and this isn't a linear process, right? I want this to happen sort of automatically. All right, so here's kind of the architecture of what I thought. And by what I thought, this is what I described to the GitHub agent and said, build me one of these, please. And sure as heck it did. So here, a little bit of a diagram it created. We've got the editor agent, tells you what it does. It manages and coordinates and does all these wonderful things. We got all those things we saw, kind of put them together. And then this is kind of what the code looks like. It's a little harder to read under that background, but this is the editor agent, right? So you can see here, he's going to instantiate. I'll draw my little pointer over here. I don't want to be left or rightist. Here's where it's instantiating instances of all those other objects. And then he's got his little system prompt. And all the while, here's the artist agent. She has her system prompt. And they do their magic, right? They work together and produce those things. And one of the other things I asked the agent was, what model should I use for this? Because I don't know if you've looked in AI Foundry. There's 479 million different agents at the moment. So it came up with recommendations for those and wire it up. So that's what's kind of in train at the moment. So hopefully that will produce and have you racing home every night to read the latest blog post, to hear the humorous stories of Todd versus Barry the bird and what's going on. So that was cool. But I have one more problem to solve. If you remember me getting squirted in the face and Barry coming from behind, I needed something that I could dissuade. I was going to say attack, and that seems harsh. Dissuade Barry, regardless of where he was. I needed some 360-degree coverage. And like everything, there's an open source project for that, right? What I'm calling the ACME Bird Defender 3000, because the twirly Shirley just didn't kind of strike the terror I was kind of hoping for. But this is something someone built basically to take photos of products for YouTube and things like that. But basically it's a little red box 3D printed, and what's sitting on the top there, and again, I'm going to get in trouble for saying this. Can you even say Lazy Susan anymore? I don't know. Anyway, it's a Lazy Susan. If you've ever had one of those things on the table that spins for the food, that's what that is. Okay, and then sitting underneath is a little 3D printed gear, and that's going to solve our problem. We're going to put the sprinkler on top of that, sitting up on the table here. If you'd like to come and have a play with it. It's not connected to the hose, so you're perfectly safe. So how do we control that? Well, casting back to my thing about MCP for a second. This is the electronics, and it doesn't need to be this big. I did it this way so it's kind of easier to understand. But if we think about it, it takes USB-C power. And part of the problem, especially when you're dealing with IoT and physical devices, this little Pi Pico here needs 5 volts. This motor over here needs 20 volts. That's not good to mix those two together. But luckily, PDC, this little tiny thing here is a little called a PDC, right? It's the interface into USB-C. So you may not know this, when you plug in your USB-C, it isn't just that the cable is symmetrical and you don't have to figure out which of the 10 ways the 2 ways fit, right? It actually negotiates. It says, oh, hi, I'm a power supply. And the guy goes, hi, I'm a device. Awesome, what do you need? Well, I need this many volts, this many amps at this many volts. And the power supply will go, well, I can do this many of this or this many of this. And they negotiate back and forth and work out what the hell power they're going to give each other. So it's a whole protocol that goes on there. So the way this one is set up, it says, these little switches are set that says, give me 20 volts. That's the only thing I need. And luckily, this is the charger off my Apple Mac, my MacBook. So it goes, yeah, sure. There you go, have 20 volts. Then sends that down over to here. And this thing is just a little power converter. You can see there, well, you can kind of see it says 20 because that's the input voltage. And I've got the little thingy tuned. So out the back, it spits 5 volts for this thing, right, into the Pi Pico. So it's doing its thing with 5 volts. 20 volts here also goes into this board, which is the motor driver. So basically the code running on here in MicroPython, because it's got to be Python, it's not cool if it's not Python, will do its thing. And then over these wires, we'll send the signal to this thing, which will turn this. And I probably should have put those boxes as I'm saying that. Seems like a lot of detail to go into something most people don't care about, but here's why I want to do it. I keep seeing lots of memes and posts and comments around MCP, oh, it's just an API, it's blah, 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 right? But it's important to understand that all this implementation detail is invisible to the power supply because of the protocol, and MCP is like that. You could have an Access database running on the, on the server that sits under Bob or Sally's desk still, and as long as it had an API, you could use MCP to expose that in a way you wanted to an agent and let an agent do its thing. So when we're trying to squirt water out of this thing, all these things only have to tell it, hey, here's what I am, here's what I can do, here's my capabilities, and the agent can discover those and work with it. That's why MCP is so important, particularly because we're off doing lots and lots of shiny things, but let's face it, probably 80% of our IT estate is still, should I say classic? Is that we've ditched legacy now, right? It's classic. It's either classic or it's like you're just not allowed to touch it. It might be a vendor system or whatever. But if it's got APIs, you can logically represent that. So that's kind of cool. So hopefully what that will give us is the Bird Defender 3000, way more successful and self-injurious than the 2000, which will basically just sit on top of the twirly Shirley. I can't do it. The twirly Shirley sits on the bottom here. And of course, what that will mean is as Barry moves around the yard, we can hopefully track him, engage him, and persuade him to get in his tree, because that was what he wanted to do. And the other reason that's interesting about this is, again, we were talking about this before start. This little thing, it's not a computer, it's a microcontroller. And traditionally, the way you described these was they do one thing and they just do it infinitely. That's how we used to think about microcontrollers. So, in your fridge, it keeps the pump going or whatever. But it's not kind of the case anymore. So with this Pi Pico, I mean, again, we're talking about a $12 or $15 bit of hardware. We're not talking a lot of money, but it's got dual cores, which is interesting, but it runs MicroPython, right? So a lot of those libraries that are available to Python, there's a version for MicroPython. So because we've got 2 cores too, that means instead of having it only controlling the, oh, by the way, it's also got Wi-Fi and Bluetooth, which is handy. So we can now split the 2 things we want this to do in our AI solution. We can say, right, one of those cores, you're going to be in charge of controlling that device, sending the signals, doing the thing and all the thing that you do with a microcontroller. The other core, you're going to run MicroPython and be an API. So we can basically divvy that up. And possibly one of my favorite, I typically love Python and hate Python roughly equal portions. But some of their naming is cool. So Pimoroni, if anyone's bought any of their hardware, they've created a thing called Few, and that seemed to fit, which is basically a web server and templating engine. And if anyone's done any classic ASP, it looks remarkably similar to that. But basically on that other core, we can run an API. We can do whatever the heck we want on that thing. So then we can expose that via MCP to our ACME Agent 3000, the next generation, to actually control it, do things and discover its capabilities. So again, thinking back to being modular, we could just start throwing more and more tools, which is kind of what this is in an MCP sense, into the ecosystem, and then the agents can do with it what their evil brains wish to do, for good or bad. Cool. I feel like I've talked very fast. Sorry about that. Did we skip? Oh no, one more. Okay. So what did we learn about tonight? Well, I have to say, as much as I mocked it earlier, the Wile E Coyote management framework, trademark, actually worked pretty well, right? Stayed very clear on the purpose and got it with it. Certainly iterative mastery. So if anyone's done lots of agile, and done some like Bean 20 training courses or talked to very advanced people, you know, you think you've broken things up into smaller tasks, but you can always break them into smaller tasks and smaller tasks and smaller tasks and smaller tasks. And this was an interesting thing. Instead of jumping to the super AI solution, actually going through that process was handy. And if you think about that in other contexts, be it a business or an industrial setting, there's lots of things you can do and experiment and learn in a thing. And accountability, actually kind of skip that step to be fair. And ethical persistence, we'll let history be the judge of that. So, in terms of the AI and the tech, though, what were the things that stuck out to me? And by the way, oh look, everyone takes forever. One day I'm going to create a QR code that goes to like a QR code generator, generate a QR code of you. That's a QR code that will take you to get in your tree, and all the resources and all the repos and everything is listed on that site. But I guess reflecting, and as Dan said, a lot of the times these talks are about super technical things, and sometimes it's just about what did you learn and what was cool. So the thing I noticed, and I've been using AI in development, you know, since, you know, a year ago, like since the beginning, like right, way back. And the quality and the output of some of these AI models now is quite astounding. It can be horrendously bad if you're trying to give it the wrong task to do. But it is amazing. That thing with GitHub, what it was able to produce in 20 minutes while I was watching the cricket, you know, from a prototype, would I go with it to production without reviewing it? No, of course not. But in terms of where it gets you so much further than, you know, the 101 samples or whatever you get off any repo you can think of. Because you can give it your specific business problem, give it your constraints, give it the tech you want to use, and it'll factor that in, right? Just amazing. Like the one I showed there with when I told it about a backyard in Brisbane, and it pretty much one for one matched up with what my data said was in my backyard. I was impressed because I didn't think it would even care about that. It did. So that was kind of cool. The other thing I learned about was the right model for the right job. It used to be easy. It's like, which of these 5 models will I use? Now there's not only thousands of models, let's say hundreds of models in the Foundry repo, there's all the variations of them. You know, do you want quantized? Do you want it not quantized? Do you want it for this hardware or that hardware? There's a lot to take in. So, and say, you wanted to say AI Foundry, Microsoft Foundry does a great job in that it kind of gives you those kind of leaderboards and those kind of information about each of the models. So really, really cool. Particularly when they tend to leapfrog each other and change so darn quickly. Like my new best friend is Opus 4.5, I think I'm still using because, you know, I'm really old and 4.6 has been out for what, a week now. So yeah, but they do leapfrog each other very, very quickly. The other thing I was going to say about that though was that it's a very different flow. So giving a problem to like a multi-agent framework is great and it produces amazing results, but you literally give it to it and you come back in half an hour, right? That's a very different feel. It's not an inner loop like what I've been experiencing, you know, using GitHub Copilot inside VS Code, giving it little suggestions and little steering. The one nice thing is, even while it's churning away, you can keep chatting to it and you can, if you know, you can steer it and do that, it's great, but it feels different. You know, so some people will love it and some people will hate it. And I think it's great for some scenarios. So in my scenario, I was really trying to do 10 different projects at the same time. And I didn't have time to go and learn, you know, what's the best MQTT server to run? How do I run it? How do I put it in Docker? I just wanted it done. And it was great for that. That was good. But if you want something much faster, much more iterative, you'd probably be picking different models and you'd be doing it in a different way. So that was kind of cool. The other thing that going through this is this concept of more distributed AI solutions. You know, I think for you know, the first 20 years of the AI boom, it's been that long, right? You know, it was all about RAG and it was all about this and it was a very set pattern and, you know, it was a flow. You could kind of picture it. Now with agents, MCP, all this other stuff, I think we're realizing there's lots of value in figuring out ways to connect different things. So we're not looking for a model to solve our problem. A model is part of our architecture. We're going to have multiple models and multiple other things inside that framework, and they all work together. And we need to think about things like my discovery with latency. You know, the HomeKit was great because I literally could just activate the thing and get it going. but the price to pay was that you had to go through that ecosystem, and that cost more time than the rest of it. So there's all those sorts of trade-offs. This is interesting. So I put interesting times for AI hardware. So I don't know if anyone's seen the announcements from NVIDIA in the last few months. Good luck buying a graphics card for your PC for the next few years. They're basically saying we don't have the ability to do that. They just need to crank out and turn out AI hardware for, not for you and me, but for the Microsofts and for the Amazons and the Googles and the whoever, the data center people. And not only that, the hardware they're bringing, if you look at a 5090 or whatever, my video card that was using this was a 3080. It's years old. But because, back in those days, in those heady days of 4 or 5 years ago, memory was pretty cheap. Now memory is expensive. Right? The price of a pie has gone up by 30% in the last month because of memory, cost of memory. So we're going to hit some interesting times about how and where we do things. Do we do it on the edge? Do we do it in the cloud? How much do we do it? Where do we do it? So it's getting kind of interesting in that hardware space. Trying to remember what I was even talking about here. Hybrid AI development flexibility. Oh, okay. So the fact that you can do it locally is interesting, right? Some of those local AI Foundry things, and particularly because, say, if you're using VS Code and you're using GitHub Copilot, you can point it to Foundry local models. Right? So for some of those programming tasks, like the simple, formatting text and doing whatever, you might say, hey, I'm just going to run a model myself on my PC. It's got a 3080 like Todd, I'm cool. And we could just run that locally. And then I don't know if you've noticed in VS Code for GitHub Copilot now, it isn't a chat window per se. It's a whole lot of chat sessions that can all happen in parallel. So you can basically have, your main, like I'm using Opus or whatever, pick from the model dropdown, use Opus, but then you might expose to it, hey, by the way, I've got this version of this model running here you can use for this task. Formatting JSON files and whatever. Don't go up to Azure or GitHub and do the 3x premium price for that. Run that local model. You do the reasoning and the logic. So kind of interesting scenarios. And last, scrub turkeys are chaos engineers. There is no other way to think of them. They just want to cause pain. And that's okay, because, what would life be like if there wasn't just a little bit of chaos in your thing? So I was doing that as a test to see how many took it first. In getinyourtree.com, the premier site for scrub turkey related material in internet, well, at least in Australia, I have put not only the framework and the tools, I've put a page which has all the repos I've created. My repos, which are forks of other repos, and you'll see the fork. Please go and show love. But my repos have my customizations I've had to do to get everything running. So, for example, the bird lens was written on the Raspberry Pi 4, and they changed things on the 5, so certain libraries don't work. So I've made changes for those and submitted pull requests, but they haven't been accepted yet. So if you want to go and look at that, you can all do. What's next is that multi-agent framework, getting that running, publishing those dramatic blog posts. And of course, what would a blog post be if you didn't also turn it into an automated agentic YouTube video? So expect that to be coming very, very soon. And of course, what would it be if we didn't also publish that as an audiobook? So Adam's out kayaking in his, I guess you don't kayak in a canoe, do you? Kayak in your kayak. Whatever you do in your kayak, he'll be able to listen to the latest and greatest news out of there. And of course, getting the wonderful bird turning platform working and hopefully not destroying anything in the process, but that's more aspirational than anything else. So that's all I've got. I'd love any questions, thoughts, feedback. What is anyone going to run off and go and play with and try?
Has Barry come back since?
Look, Barry and I have a complicated relationship, and I'd have to say, and I didn't put the video in, but I was interested to get a text message yesterday from my wife that said, there's 3 scrub turkeys in the backyard. Oh, no. So, and this is the, remember this part of the framework, failure is just a data point. I looked out and you know what? There were 3 scrub turkeys in my yard. You know what? Barry wasn't one of them. I think it was Barry's wife and his 2 small children. So, look, I'm going to call that a win. Some may choose not to see that as a win. I'm confident though, once I have the targeted system up, look, it'll improve success by at least 3%. I'm happy to get the math.
Maybe they learned where to get a free shower.
3%. Sorry?
Maybe they learned where to get a free shower.
Well, I've already got that free shower. Yes, but look, I don't know if it's unethical.
Have you improved the reaction time? That last bit that you mentioned?
No, so that's my key thing. I've got to figure out that. And I didn't realize this, but you know, you buy all these home automation ecosystems, right? So you've got HomeKit and you've got the Googles and the whatever. They just never talk to each other. They were their own worlds. That's changed. I didn't know that. I don't know about Thread.
Yeah.
Yeah. So basically, I don't know how, everyone got together and went, this is a bit dumb. So they basically got this protocol. It's kind of weird. Some of the terminology they use is weird, right? But I'm going to call it thread. So I'm thinking this is like MCP. So basically, it's a way that any of these ecosystems can adopt and talk to devices in all the other ecosystems. I suspect that will make it slower. I don't know. But that's definitely something I have to do. Or alternatively, well, there's two options, putting on my Wile E Coyote mindset. The first is to figure out the actual manufacturer. There is an API, but they don't publish how to do it. Second thing is I get a screwdriver and I open up the back and I find a way to plug it in. But that is, in all honesty, one of the biggest challenges. Or alternatively, I don't do that. So I bought that tap because it was super easy. I plugged it in. There's no reason I could put a water pump with another microcontroller and I can just do it myself. That would be the lowest latency of all.
Just a water valve, something that.
Correct. Correct.
An ESP with some.
Yeah, but again, I was trying to buy, not build, and swings and roundabouts. Any other questions, thoughts, ideas?
I have a tip for you.
Oh, please.
That issue, like I think you can run Home Assistant locally instead of like talking to.
Well, I put it on. And again, because it's Apple, you can run a hub locally, but only on another device they just happen to sell, either an Apple TV or a HomePod. So I bought a HomePod, and I'm doing that, but it's still slow. So I don't know whether the interface and how you configure that is a little bit black magic. So it may be that it's not doing it, and that could fix it, which would be great.
Yeah, I'm pretty sure there's like an open source that people
have to look
just
at that.
like jam, all of these different IoT devices in to
That would be cool.
with less latency,
Yeah.
I just want to turn on.
I mean, look, and to be fair, Barry doesn't move super fast. I'm not going to suggest hitting him's incredibly difficult. But the more targeted the thing is, then the more latency matters, right? Whereas at the moment, it's an area effect. I nearly said weapon again. It's an area effect device, so it's less important. But also, it will become important where, remember, I don't want to squirt the other birds. So the longer the latency, the higher the chance I'll actually squirt one of the birds that we want to. And because our neighbours also feed the birds, so there's a little bit of competition going on. And, if you live in the Gap, you're probably on the Gap Grapevine Facebook group. Lots of people posting pictures of those same birds. So I think they're the most well-filled birds in Brisbane. So I don't want to do anything that will put me on their blacklist, right? That's just not something I'm prepared to risk.
I mean, it's only water. It's not like
To you and me, it's water.
It's not like it's another liquid like gasoline.
But why go to a backyard?
Exactly.
Water squirting when I can just go to the other one.
Exactly.
Much nicer.
Yeah.
Much more.
Competition's tough.
I'm just getting into that whole animal ecosystem and learning about positive reinforcement. I'm wondering about maybe if you could have make a lure that actually is. It's like getting rid of the way to get rid of possums is to throw apples onto your neighbour's roof.
Right, what's first? Your ethics are your own, I guess.
That's a way we can build something where you're luring Barry into the neighbour's yard.
Your neighbours love you.
We like our neighbours, so I'm probably not going to go. But yes, although again, throwing food into your neighbour's yard could also have some detrimental effects. Just thinking that through. But so what would be interesting is, what about if you extended this system so it wasn't actually your yard? everyone in your street have. Because then hopefully scrub hookers go, oh, look at this, we'll go down to the neighbouring street. So, you know, they're saying you live in the gap and you're interested in building. Give that a try. I don't know if a swarm of them would be the correct collective noun, but I think everyone loves swarms. So yeah, let's have a swarm of them. I did think of drones, but that got way too hard. Like, great, I got 15 minutes of flight time if I don't go too far. And then the
You
whole.
know, it's illegal to harass the rooster.
Yeah, that's the thing. As I said, they're protected. They're the least needed thing of protection in the entire animal kingdom. Right? They have nothing of value. They don't contribute. So, but they're protected. So what can you do? So anyway, I'll leave you. If that's the case, let me just leave you with one last view of Barry getting his comeuppance.
Is that a honeypot? Are you luring Barry in?
Solar powered sprinkler, and I'm sticking to that story. But you'll notice even when he leaves, there's no terror. That's like, all right, I'm out of here, but I won't forget. You know, like, that's that's not going to do. And then, of course, my personal favorite: get in your tree. And I think I've said it enough now because whenever I say get in your tree, my daughter automatically answers .com. So the message has gotten out there that that's definitely the way to go. All right.
As always, without disappointment, your presentation was not only informative, but very entertaining. So full marks on both of those. And most importantly, no bush turkeys or coyotes were harmed in the process. So we don't have to.
Not according to my lawyer.
But and as always, we always appreciate our the speakers. So thanks so much. So thank you everybody for coming. Do come next month. I believe we have Adam